Hi everyone, welcome to coding tutorial 9 of neural networks and deep learning. My name is Everly. Today we're going to learn how to load a pre-trained semantic segmentation model using PyTorch, and then we're going to inference that model on a data set. And then for that dataset benchmark, we're going to apply evaluation metrics and generate quantitative results. So there are simply two steps. First step is to load the model, download data, and then inference on that data set. And then the second step is to generate quantitative results based on the model results that we generated in the first step. And as usual, mount your drive before starting. And today we have this data set for you to download. Um, so the semantic segmentation model that we are running today is called fully convolutional network, FCN. So this is the paper for this model. And so basically, it's a semantic segmentation model, and we'll come back to this later. For the coding part, it will be simple. If you download this data set, I named it Cocoa Data. It contains 10 images in there. And if you go to the images folder under the root folder, you will find the JPG files for the 10 images. Now, to start, let's first create the model, the pre-trained model, and then load the images for inference. So, um, let's load the images for the image path we have here. And list the files. So for image name in there. And if, just to make sure there aren't other files read, after compression, sometimes there can be some other files. And with the image names, we can read use CV2 again. So, okay, actually, I need to run this. So we import OS CV2 and we need torch vision so that we have the tensors to tensor, and then the model itself should be this one. That's the model from this paper. So it says that we can just call it, and there's pre-trained weight. And for this model backbone, it's ResNet 50, and there's all sorts of information. So it says that it is trained on a subset of COCO dataset, and with only 20 categories, those are the Pascal VOC dataset categories. And this is the model that we're going to run today. So first, from Torch Vision, models segmentation, import FCN, that's our model, ResNet 50, and we can just call this and set retrained is true. Okay, so now we have the model ready, and recall in our last lecture, for evaluation, again, we're not going to train a model today, we're just going to inference on it because we don't have the resource to actually run training. And we also need the predictions. All right, now we're ready for each image. From the image names here, read the image using CV2 IM read and OS path. Join the image path with the image name. Okay, and then we need to do convert color. Recall we talked about this in the coding tutorial 8, that the color channels can have different orders, so we need to now we're reading in BGR, we need to convert it to RGB so that we can input it to PyTorch model. Now, with that, the image is ready. So for prediction, again, recall in the last tutorial, we need to call torch no gradient. And with that, we can run the image. So first of all, the image should be transformed into tensor, and then we need to further, let's call it image tensor. We need to further add a dimension to it. So that'll be none and everything else. So now this is a tensor with the shape of the image plus one dimension. We can print the tensor shape to make sure that we're on the right track. So now it's loading the model. BGR. Yeah, that was wrong spelling there. So now we have the first dimension, that's the batch size. We're just inputting one image at a time. And then three color channels and height and width. All right, so with that, we can run the output and just let the model predict from this image tensor we create for each image. For predictions, append the output. All right, there should be no surprise till now. So let's run this cell. This model needs to use some time to run this. So while it's running, let's take a look at what all this is about. So, in the previous coding tutorials, we mostly worked on classification tasks. There were some other data sets, and there are some image data sets, and all the tasks were classification. And recall that to evaluate these how well the model is doing on these tasks, we usually used metrics such as accuracy, precision, recall, and we even provide confusion metrics, that sort of evaluation methods. So those are the standard methods in classification. Even though we used a lot of classification models and data sets for example, but in deep learning area, there are so many very diverse different tasks. For example, in the last coding tutorial, number 8, we loaded an object detection model. And in this tutorial, we're loading a semantic segmentation model. And these models have different outputs. For object detection, we drew the bounding boxes for qualitative results. And today we're going to talk about quantitative results. So quantitative results are referring to on the benchmark on the data set. We use the standard metrics to evaluate how well the model is doing on this set of data. So what's important is that there are too many different tasks in deep learning area. And now we're looking at two different computer vision tasks, object detection and semantic segmentation. And in the future, we're going to look at some natural language processing tasks. So these are all different. And there's no need to worry about not being familiar with all the tasks. Basically, it's very hard to master everything. And you don't even need to remember everything. But an important skill here is for you to when you need to work on a new benchmark, a new task, to go through the documents and understand what's the requirement in this benchmark. So in part two, we're going to do a practice on this. So to understand what the benchmark is about, first of all, the most important question to ask is, what is this task? And second, what is the annotation format? And third, what are the evaluation metrics for the task? So with the simplest example, let's say image classification for MNIST, the digit dataset. What is the task? The answer would be image classification or image recognition. And the second, what is the annotation format? The answer would be it's a number, an integer indicating which category this image belongs to. And then the third question, what are the evaluation metrics for this task? The answer would be accuracy, precision, recall, F1 score. So so that's the simplest example there. Now, there are more like much more complicated tasks. So let's take a look at COCO dataset and learn a little bit about this benchmark. So recall that in tutorial number 8, we talked about object detection. So let's take a look at the COCO dataset object detection to see what's going on there. So if we visit COCO's website, you can see that there's dataset page. So we can take a look at the dataset. So you can download the images here. You can download the annotations here. And there's overview. And it tells you that you can use COCO API to load the dataset, load annotations and images, and evaluate. And this is about this dataset. And then for detection, object detection, we can take a look at the task. say detection task 2019. Here's an overview of what this is about. There are bounding boxes. There's also the segmentation over an object and how it works. All that information is in here. And we can also check out how to evaluate it. Again, in evaluate, go to detection. So here it tells us that the metrics to evaluate the model is average precision, AP across scales, average recall to, and AR recall across scales. So these are the metrics if you are benchmarking, if you're running this model and benchmark on the COCO data set, then these are the metrics that you look at. So this is the idea of how to understand a data set. And now let's use our toy data set as an example. So this data set is the same link that I put in part one. So you don't need to download it again if you've already done it. So let's look at the description of this data set. So this data set challenge is called COCO data. I just named that randomly because I got all the images from COCO. It's a subset. So the task itself is semantic segmentation. So for semantic segmentation, we need to understand it a little bit more. So basically, this kind of models, they predict the segmentations by class. So it should give us something like this as an output prediction. With the input image, the model predicts where the horse category is by a pixel map, and also it predicts the human segmentation with a pixel map. So this is the task. We need to first understand what semantic segmentation is. And then let's come back. And the annotations are the 20 categories in Pascal VOC with the order from 1 to 20. So if you're interested in what categories are in there, you can visit Pascal VOC. And it says 0 means background. So the last thing for evaluation metric, use MIOU. And if you don't know what this matrix is, you can visit this COCO website. It explains what's MIOU in evaluating semantic segmentation predictions. So this is all about this data set. Let's revisit the important questions about this benchmark. What is the task? The answer is it's semantic segmentation. And what is the annotation format? The answer is it's a category map, like we see in here. And within this map, it says that the number 0 would be background, and then for the 20 categories, it should be labeled as 1 to 20. And what are the evaluation metrics? So the evaluation metric here is actually just the MIOU that we're using. Okay, so with that, let's try to benchmark this data set by providing quantitative results according to the descriptions here. So first of all, we need to write a function to generate the MIOU score. So let's start with using this scikit-learn package function Jaccard score. So the description here tells us that it does basically it helps us calculate MIOU. So IOU means intersection over union. And so if you're not familiar with that, You can Google it. And this is the definition of intersection over union, which is the overlap part divided by the union of both prediction and ground truth. So with that, we can call this function and then apply two arrays to see to calculate the score. So from scikit-learn metrics, import checkout score, and then let's write a function called MIOU. Input the ground truth and prediction. So it can also calculate two-dimensional data, but for simplicity, let's just flatten it. Oops. Ground truth call flatten. This is a function in NP array, and prediction flatten so that everything is still in the same order if you have the same size of ground truth and prediction. And then MIOU score would be called the Jakar score. And average, that's for the mean IOU. And we can use macro. And there are different calculations for how to find the mean. You can visit scikit-learn to find out what's the difference. And then return MIOU, the score. All right. Now, the prediction is done running. So now we can take this predictions and take a look at what we got. Because we stacked the predictions of the 10 images together. So let's take a look at the first one. Let's print the first one, let's say the type. All right, so it's dictionary. For a dictionary, we can first look at what are the keys. So it has output and aux. So we're going to take the output and let's take a look at what that is. Okay, so it's a tensor with all these numbers. Let's take a look at the shape. So this corresponds to the shape of the first image input. And so again, the first dimension is the batch size. And here you can see there's a second dimension with 21 channels. And here it means the order the categories from 1 to 20 and plus the background. So that would be the output. And that's the predictions for each pixel in 422 by 640 image. The 21 channels refers to for each categories, including background, the prediction of probability. So we need to do first find which one is the final decision. So for prediction in predictions, we will find the predicted map is torch dot max, and then prediction get output. This dimension is 1. It's the second dimension, this one, and then turn it into an array. And let's see what the map looks like now. We should take the first dimension because we can get rid of this. So, all right, print the shape of this. Uh, all right. So now we get the image. So this is the prediction for an image with the number. It should be the category from 0 to 20. And that's the result. So now we have get what is the result from this model output. Then we get the category map, the prediction, and in the annotations data, in the dataset annotations, we have the ground truth. So we're going to compare this to that and calculate MIOU score. So to do that, um, we need to first load these annotations. And here I have already put the annotation paths over here. So let's read that. Um, the annotation file names should be for the image name in the image names list. And then for this name, we need to split it because it was originally JPEG file. And then for annotation, it's PNG. So this should be the annotation file names. So for each prediction with the same order, we can zip the, oh, sorry, we can zip the annotations with the prediction. And then for each loop, we read the annotation. Join the and path and the name, and then read it in grayscale because it should only have one channel with number 0 to 20 grayscale. All right, so now we have both the annotation, that's the ground truth, and prediction map, predicted map, that's the prediction available. So we can just call MIOU and calculate the ground truth here and prediction. And we can have scores here to store all the scores and then just append. All right, now we should have everything ready. Let's print the final score, the calculated MIOU of this validation set is 2.2, and just print the mean of scores. All right, let's run this cell. So what we were doing here is to benchmark on this data set, this toy data set, that I created using the evaluation metric that is assigned for this benchmark. And we got this final score of MIOU. All right, so that's everything for this tutorial, and we got the quantitative results here. So in today's tutorial, we learned how to load a pre-trained FCN model, the fully convolutional networks model. That's a semantic segmentation. And we learned how to inference on a set of validation data. So we get the predictions stacked together. And then for evaluation, we unpack that. And then based on what we understand of the benchmark, we write an evaluation function to calculate the MIOU score. And then with that, we will know how well this model does on this data set that we benchmark. And then we can compare this standard metrics to other models. So we didn't practice how to train this model, but with this pre-trained model, you can always fine-tune it. And if you can get GPU resource, you can train it on other data sets, train it on more data to see if you can train a model that's better than this. And that's all for today's tutorial. See you next time.